Advanced Math Ladies, this is lesson 1.5 titled Applications and Modeling with Quadratic Functions. Of course, you've probably already gathered that it's nearly all word problems, but here we go. Let's start with number 2. Oh, let's hope the pen will work. There we go. Number 2 says that if a rectangle is r feet long and s feet wide, which one of the following expressions is the length of its diagonal in terms of r and s? And if you look in the margin, they drew you a picture. One of the key things to be able to work these problems is to draw a picture. Well, if this width is s, so is this width. So I hope you remember how to find that, because if this is a rectangle, that has to be a right angle. So then we would have r squared plus s squared, and for the sake of what we're doing, I'm going to call this equals d squared. Well, I don't want the diagonal squared, I want the diagonal, so I need to take the square root of both sides. So the square root of d squared is d is equal to the square root of r squared plus s squared, which is answer C. The next one I want to look at is number 8. Number 8 says to find two consecutive even integers whose product is 224. Before we start the problem itself, I need to talk to you about consecutive integers. Consecutive, which I assume you already know, means in a row. We've won the state championship in basketball 6 years consecutive. That means back to back to back to back. But if you're dealing with consecutive integers, if x is your first integer, then you're going to add 1 to get to the next one, so that would be x plus 1. Well, you're going to add 1 more to that, so that would be x plus 2. And you're going to add 1 more to that, which would be x plus 3. Those are your consecutive integers for working problems. But then we talk about consecutive even. If x is your first even number, so over here we'll put an example, which is 2. The next even number is 4, so we had to add 2 this time instead of 1. The next one's 6, so I'm adding 2 more to that one, so x plus 2 is x plus 4. And the next one's 8, so I have to add 2 more to that, so x plus 4 plus 2 is x plus 6. And you can keep on going for however many you need. But this is the one that most students have a hard time with. Consecutive odd integers. Because the consecutive even was 2, 4, 6, they assume that consecutive odd ought to be odd numbers. Well, let's look at it. If we start with 1, which is definitely an odd number, and we call him x. To get to 3, what did we add? Well, we added 2, so this is x plus 2. And to get to the next one's 5, so that would be 2 more than this one, so x plus 2 is x plus 4. And if we go to the next odd number, it's 7, so we have x plus 4 plus 2, which is x plus 6. So if someone says that to solve a problem with consecutive even or consecutive odd, you use the same symbols, that is true. Okay, now back to number 8, before I got distracted. Find two consecutive even integers. So if you look at your list, the first even integer would be x. Then the second one would be x plus 2, whose product is 224. So that means we're going to take the first number times the second number, and it's going to equal 224. So we distribute x squared plus 2x equals 224. Well, since we're going to have to factor to solve this, let's go ahead and move the 224 to the left, which would mean we need to subtract by 224. So we have x squared plus 2x minus 224 equals 0. For sake of video time, we would need to list we're doing AC is 224, so you'd need to list the factors. But for sake of time, I'm going to tell you that down this list is 14 and 16. So then that means we would have x squared plus 16x minus 14x minus 224 equals 0. If you'll remember, the 2x comes from the 16x minus the 14x. Okay? The common factor between the first two is x, which leaves x plus 16. The common factor between the second two is negative 14, which leaves x minus 16. And that equals 0. Well, we have a common factor here of x. Oh, I'm sorry. This is minus. Negative 224 divided by negative 14 is a positive 16. Sorry. So then we have a common factor of x plus 16. And the other factor is x minus 14. So we have x plus 16 equals 0. So x equals negative 16. Or x minus 14 equals 0. So x equals positive 14. Okay? Let's look at this. Because your first thought is, well, I can't use the negative answer. Well, let's just check that out. If we use negative 16, negative 16 plus 2 is negative 14. Is that indeed an answer possibility? Yes, it is. Now let's look at the 14. 14 and 14 plus 2 is 16. Is this an answer possibility? The answer is yes. So both of those are answer possibilities. We don't often think of the negative as having consecutive even integers that would do the same thing. Okay, in my notes, I skipped to number 5, so I'm going to go backwards for just a moment and work problem number 5. Number 5 says, find two consecutive integers. So this time we're not looking for even or odd, so the consecutive integers are x and x plus 1, whose product is 56. So that means the first number times the second number has to equal 56. So you distribute x squared plus x equals 56. In order to work this, we need to put it all on one side. And when you do the AC factoring, you've got 56, so 1 times 56, 2 times 28, and we end up with 7 and 8. So this would be x squared plus 8x minus 7x minus 56 equals 0. The common factor in the first two is x, which leaves x plus 8. The common factor in the second two is negative 7, which leaves x plus 8 equals 0. So then we have x plus 8 as a common factor, which leaves x minus 7. If you take x plus 8 and set it equal to 0, then that x would equal negative 8. So if we come over here, negative 8 plus 1 is negative 7. Is negative 8 times negative 7 positive 56? Yes, it is. Therefore, that's an answer. Then we look at the x minus 7 part. So x equals 7. So if we use this answer, then x is 7. 7 plus 1 is 8. Is 7 times 8 56? Yes, it is. So again, we have two answer possibilities. Now let's look at problem number 16. says the lengths of the sides of a right triangle are consecutive positive integers. Got a right triangle. Now you got to be careful how you label it. The legs have to be smaller than the hypotenuse. So if we're doing consecutive integers, this would be x. X plus 1 would be x plus 1. And x plus 1 would be x plus 2. So that we have the longest side for the hypotenuse. Well, how do we do anything with a right triangle? Pythagorean theorem. So we have x squared plus x plus 1 squared equals x plus 2 squared. This one's already able for us to multiply, but we're going to have to put the x plus 1s like this. In order for us to do FOIL and not forget one of the components. So we have x squared plus x times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. And then on the other side, we have x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Okay, we need to combine like terms. So x squared plus x squared is 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. In order to factor it, to solve it, we need to put everything on one side. So let's subtract x squared from both sides. Now we have 2x squared minus x squared is just x squared plus 2x plus 1 equals 4x plus 4. Subtract 4x from both sides, and you have x squared minus 2x plus 1 equals 4. Okay, then we need to subtract 4 from both sides. So now we have x squared minus 2x minus 3 equals 0. Well, 3 is, for AC, is equal to 3. Therefore, our factors are 3 and 1. So we have x minus 3 and x plus 1 equals 0. So this x is 3. This x is negative 1. If you glance back at the problem, on number 16, it says positive integers. So that leaves the negative 1 out for a possibility. So if 3 is the shortest side, then the next side is 3 plus 1, which is 4. And the last side is 3 plus 2, which gives us 5. And we all know that 3, 4, 5 is a right triangle. This should allow you to do the multiples of 3 through number 18.